The OSIRIS-REx mission is an asteroid sample return mission, and the main goal is to collect 60 grams of pristine sample from the surface of the near-Earth asteroid Bennu. Bennu's rocky surface presented a challenge for the original LiDAR-based approach to the touch-and-go sample acquisition event. As an alternative, the project developed an onboard optical-based approach called natural feature tracking. NFT requires detailed three-dimensional maps of the surface of Bennu. In order to build those three-dimensional maps, we need many images of particular patches of surface on Bennu itself.
And so all these surveys we've done throughout the mission have been at distances between several kilometers from the asteroid down to just a few hundred meters from the surface. And based on those different perspectives and what the shading of that terrain is, it's possible to build a 3D model. Very similar to how we have two eyes that allow us to have depth perception of what we see. NFT requires multiple features across the field of view to have a depth perception.
The original tag accuracy requirement was to touch the surface within a 50-meter diameter circle. Based on Bennu's rough surface, our actual performance has to be much better than that, at 10 meters or less. And even within that 10-meter area, there could be smaller localized hazards that may damage the spacecraft.
Right now, we are working on a flight software patch to help us avoid hazards as we come in for a sample event. When we do natural feature tracking, that is all autonomous on board the spacecraft, where we load the features or a catalog to the spacecraft, so we are telling it where we expect these features to be.
So as the spacecraft makes its progress down to taking the sample, we're recording images and then locating those landmarks to make sure we're on the right track. And if there's any issues with the trajectory or we see landmarks where we shouldn't, we know something's up and we can back away and wave off the attempt, try again.